The third problem of convolution integral. So they are asking us to evaluate this particular integral. Since this is continuous time signal, it is called as integral. Fine. Discrete time signal, it is called as sum. Everybody understand that? Now, these two signals that's given here are u of t plus 1, okay, which is left-sided signal. Why I call this as left-sided? Because this starts at -1 and goes till infinity. U of t plus 1 starts at -1 and goes till infinity because u of t plus 1 is shifting u of t to the left by one position. Similarly, u of t minus 2 you have. Okay, what is the range of this? If u of t plus 1 ranges from -1 to infinity, where do you think u of t minus 2 ranges from? Where to where? Anybody? What is the range of u of t minus 2? U of t minus 2 ranges from 2 to infinity, and this ranges from -1 to infinity. Fine. So in this equation that they have given, okay, let us call the first signal as x1 of t and second signal as x2 of t. Fine. Now if we write the convolution integral equation, okay, so this is how it is going to look like. Now, if this is x1 of t, x1 of tau would be just replacing this t by tau. So that we have taken as the first signal here. And the second signal in the convolution integral equation has become x2 of t minus 2. That means this x2 of t should now become x2 of t minus 2. That means this t needs to be replaced by t minus tau. Okay. So if you replace this t by t minus tau, it looks like this. But this is not the form that we required this to be in. We want this signal to be expressed in this particular form. This is very important form. Okay, so if you don't express it in this form, okay, so the problems cannot be solved. Fine. So this has to be represented in this particular form. Now let's just identify these signals. Fine. What is this signal? U of t plus u of tau plus 1. This signal is, okay, 1 from -1 to, it's 1 from tau equal to -1 to infinity is this signal. What is this signal? This signal is 1 from tau. Anybody would like to go with that? What is this signal? Can you identify this? This is with respect to tau. X-axis is tau now. It is u of minus tau first. You have to sketch u of minus tau. And once you sketch u of minus tau, what is u of t minus 2 minus tau? It ranges from minus infinity to t minus 2. So it is shifting u of minus tau to the right by t minus 2 units. So that is this. So that we have sketched here. Everybody see here? U of tau plus 1 is 1 from -1 to infinity, and u of t minus 2 minus tau is 1 from minus infinity to t minus 2, and in both the cases, once the signals are within this integral equation, the x-axis is tau, not t. Understand that? And this is stationary signal. The first signal is always stationary signal, okay, and this is moving signal. So how to identify moving signal and stationary signal? See, in moving signal you have tau as well as t, whereas here you only have tau. Okay, so that is the one which deals only with tau is stationary, which needs to be written first. Okay, the one which has both t and tau to deal with is moving signal, and that needs to be your second signal. Now we have to find the convolution integral, and again in convolution integral you have to see how many cases are there where the signals would overlap and in which case the signal will not overlap. Okay, since both the signals are infinite length signals, it would just be two cases. In infinite length signals, okay, it's just two cases, which is case number one, no overlapping range. Case one, let me just show you how it looks like. Fine, the signal which is not moving is this. So it goes from -1 to infinity. This is stationary, and moving signal is this. This is t-2. So this is what is the first case. And in first case, what's happening? So first case is when t-2 is less than -1, or that is t less than +2 -1, because 2 goes on the other side of the equation. Fine. So it is t less than 2 minus 1, or we can finally say it is when t less than 1. So this is the case. So when t less than 1, is there overlapping happening? It is t minus 2 less than -1, but this cannot be written as it is. So we just went further to see what it actually is. So that is t less than 2 minus 1. So that is as good as saying t less than 1. Okay, in this case, no overlapping is happening. See here, t minus 2 is less than -1, or in other ways, in other words, t is less than 1. Okay, so there is no overlapping happening. Fine. So we can say no overlap. No overlapping, you can say. No overlapping means no overlapping of the signals. So this implies that our y of t is 0. For what? That needs to be also written. For t less than 1, it is 0. Fine. Let's see case 2. Before we write that, let's just sketch these signals. You'll have idea regarding what's happening. I'm again writing a signal which is not moving. So -1 to infinity. Fine. Another signal that's moving is this. And let's say our t minus 2 is here now. So which case is this? Overlapping is there. I understand overlapping is there. Okay. And overlapping is from here to here. This is the overlapping range. Fine. It's overlapping case, but which case is this? This case is when t minus 2 is greater than or equal to -1, because if it is there on -1, then also there is overlapping. If it goes beyond -1, then also there is overlapping. Understand that? In this case, in the previous case, we are going from what? -infinity to, it says t less than 1. So that means t equal to 1 we are not considering. So that needs to be considered here. Fine, let's see if it is t less than 1, what is this supposed to be? So this implies it is t greater than or equal to 2 minus 1, or t greater than or equal to 1. So we have to cover the whole x-axis tau. So that means what here? See, it's t less than 1 means it's from -infinity to 1, it is this, and from 1 to infinity it is this. Okay, there is overlapping range. So overlapping range is what now? overlapping range is there, that is tau equal to -1 to t minus 2. Understand? So here is equation number 1, which needs to be dealt with now. So this is equation number 1. We should just write equation number 1 here and say, therefore, equation 1 implies it is y of t, okay, integration tau ranging from. Here now in the overlapping range is this, so we need to go with tau ranging from -1 to t minus 2. And see this signal from -1 to t minus 2. What is this stationary signal and what is this moving signal? Which is as good as this. This is stationary signal, this is moving signal. That is what is overlapping here. In this overlapping range, what values these signals are assuming? These signals are assuming values 1 and 1. So this is how our equation 1 looks like now. Fine. So it is as good as saying this. See here? Instead of saying tau minus 1, I'll say it is tau plus 1 equal to 0. If it is tau plus 1 equal to 0, what is this upper limit? Let's see how many of you have understood that. If I write the lower limit as tau plus 1 equal to 0, what is supposed to be the upper limit?
T minus 1.
T minus 1. That means it is as good as doing this. T minus 2 plus 1. Isn't it? Because here tau plus 1 and minus 1 plus 1 we have done. Okay, so this it is as good as doing add plus on both the sides of the lower limit. Add plus to both the sides of lower limit. So if you're adding plus 1 to this equation on the lower limit, this is how it looks like. And if you're doing it on the lower limit, you're not supposed to forget to do it on the upper limit. Okay, so it becomes t minus 2 plus 1. Or let me write this also. So the intention is to have it from going from 0 to the upper limit. Okay, so it is -1. So this is what we have done. So you need not have to show this in this detail. It is understood. Okay, so what is that we've done is this. So tau plus integration tau plus 1 going from 0 to t minus 1 d tau. So this is what it is. Understand? Now there is no standard integral as we were seeing standard summations. Understand? So we could have done it here itself actually. Yes. Very sorry. Very sorry. When there is no standard integration, we need not have to do even this. Very sorry. You can just strike it off. So what we have done is fine. From 0 to t minus 1, if we apply, we will get. But there is no necessity of doing this in what? Convolution integrals, because we don't deal with the standard integrals where when we are summing up, yes, we do that. So it is as good as this only. So it is tau ranging from -1 to t minus 2 1 d tau. Okay, so what is integration of 1? Integration of 1 with respect to tau is tau. Okay, and apply the limits -1 t minus 2. It's just this. Fine. So it looks like t minus 2 minus of -1. So it would be what? Therefore, y of t is, what is it? T minus 1 for t greater than or equal to 1. Understand that? So this is how the signal is. This is how the output is. Now you need to summarize this. Can you summarize this yourself? Summarize these results. Summary of the results we should write. What is that summary? Y of t is 0 for t less than 0, and it is t minus 1 for t greater than or equal to 0. So this is one way of dealing with it. Fine. So your y of t is this. Fine. In compact form, how we can write in terms of unit step function? Can you tell me that, anybody? How can I write this in compact form using the shifted version of u of t? So what is the range now? Range is from, oh, what am I doing here? It's not less than 0. Don't tell me that. I've been making mistakes here. So it's t less than 1 actually. And it is t greater than or equal to 1. Fine. So the range is, so it is 0 for t less than 1, and it is t minus 1 from where to where. If we say it is from greater than or equal to 1, it is from 1 to infinity. And which is u of t, which is 1 from 1 to infinity? So should come here. Anybody? So this t minus 1 should be multiplied by what? Should be multiplied by u of t minus 1. So this is how we can conclude the results or summarize the results. Fine. So let's go with the fourth one now. Fourth problem for you. So that is this. Obtain the following convolution integral. That is given as y of t equal to e power minus 2t u of t convolution integral u of t plus 2. Fine. So this is the problem that's given now. So as we did in the previous case, let's consider this first signal as x1 of t and the second signal as x2 of t and write the equations. Fine. So let's do that now, everybody. In the solution, call the first signal as x1 of t. Let x1 of t be e power minus 2t u of t. x2 of t be u of t plus 2. Therefore, our y of t is integral tau ranging from minus infinity to plus infinity, or before writing that, let's write that x1 of t convolution integral x2 of t, and this is integration tau ranging from minus infinity to plus infinity. x1 of tau, this is x2 of t minus tau d tau. So if we bring this x1 of tau and x2 of t minus tau, okay, how this equation would look like is the question. Therefore, with the given signal, this y of t would now look like integration tau ranging from minus infinity to plus infinity. Okay, so if this is x1 of t, writing x1 of tau is just replacing t by tau. That is e power minus 2 tau u of tau. Fine. And the second signal is this. So it is u of t plus 2, it says. So thus u of t plus 2, in this u of t plus 2, t needs to be replaced by t minus tau. Okay. So it becomes u of t minus tau plus 2 d tau. Now, how do you write this signal, anybody? How would you write the second signal so that the sketching becomes easier? Somebody please comment on that. So if you engage yourselves in answering and interactions, then you will learn. Otherwise, you cannot focus. If you are noting, if you are preparing the notes, as and when I put things on slides here, then you will learn. Otherwise, no. And along with that, you also need to evaluate the things. Fine. How would you like to rearrange this particular signal? So by experience, you should be able to do all that. So if you're not able to do all that, means you're not involved here. Passive participation, not active. You're not there actively. Physically, you're there. Okay. Now just sketch that. Sketch this signal. What is this signal now? This is decaying exponential. Fine. From tau equal to what is that? 0 to infinity. This is the first signal. And this is stationary signal, mind you. What is this signal? Anybody? This signal is 1 for tau ranging from where to where? It is 1 from tau ranging from minus infinity to t plus 2. Very similar problems we have been doing. So you should not have any issues understanding this. So let's sketch now. Let's sketch the stationary signal first and then go with this moving signal. So the people moving from the dugout, the same scenario. Okay, so there the samples were shown here. The signals are continuous. That's it. Fine. So e power minus 2 tau, right? So how does that look like? How does that look like? See here. Now let's take. So anyways, whenever it is raising or raising or decaying exponential at 0, its amplitude would be 1. And since it is decaying, see here, it comes from here. It comes from here, becomes 1 at 0, and from here it goes to 0. This is what is the signal. Understand that? So, but since it is ranging from 0 to infinity, what we do, we just limit our signal from 0 to infinity like this. Understand this? Okay. So this is decaying exponential ranging from 0 to infinity, and at 0 it is 1, and this is tau. So what we have written is this e power minus 2 tau, okay, u of tau. And what is this signal? This signal is e power minus 2 tau. Fine. Now let's write the moving signal now. So this moving signal is from minus infinity to, it is 1 from minus infinity to t plus 1, right? So that signal is this then. We need u of t plus 2 minus tau. If this is your, excuse me, if this is your tau, okay, then this is what is your, this is 1, okay, t plus 2. Understand? So this is 1 from minus infinity to, let me put dots here, t plus 2, and this is e power minus 2 tau from 0 to infinity. Fine. So case number 1 now. Case 1. no overlapping case needs to be given. So how to give the no overlapping case? Let's write that for your clarity. So this is stationary signal. So this is 0. So this is moving signal. Okay, and this is t plus 2. So which case is this? This is when t plus 2 is less than 0. So which implies it is as good as saying t is less than minus 2. So when t is less than minus 2, is there any overlapping happening? No. For overlapping to happen, this t plus 2 should at least be equal to 0, or if it is, or it can even be greater than 0. So when t plus 2 is equal to or greater than 0, then there will be overlapping of the signal. But since it is less than 0, no overlapping is happening. Understand that? So we can say no overlapping which implies that y of t is 0 for t less than minus 2. So this is the first case, no overlapping case. And we are covering which range here? We are covering the range from minus infinity to say minus 2, let's say, or minus 3, let's say, minus infinity to minus 3. Or since it is continuous time signal, we can come till minus 2, not a problem. Now let's see case number 2. Case 2, let me just give you that scenario with this graph. So this is again a signal which is what is this signal? This is e power minus 2 tau, right? And we need to have a signal which is moving now, and this moving signal would now go beyond this 0 and come somewhere here. Let's say this is t plus 2, right? And what is this signal throughout? It is 1. This red signal is e power minus 2 tau, and this blue signal is 1 throughout. And in the range of overlap, what is this we shall see? What is the overlapping range? 0 to t plus 2 is the overlapping range. Fine. So let's come to that. But before that, we need to see which case is this. It is the case where t plus 2 is greater than 0. So this is when t plus 2 is greater than 0, or it is t greater than or equal to 0, mind you, okay? T greater than or equal to minus 2. So this is the case. So in this case, what would your equation number 1 look like? See here, this is where your equation number 1 is. This is your equation number 1. Fine. So you don't have to see anything in this equation. You can just simply see in this plot or sketch, which clearly says that equation number 1, or overlapping range, we need to write first. Let's write the overlapping range because there is overlapping happening. Overlapping range would be tau equal to 0 to t plus 2 is the overlapping range. So one that is shown in what? Yellow color is the overlapping range. Fine. So therefore equation number 1 implies that y of t is equal to integration tau ranging from where to where? 0 to t plus 2, the overlapping range. In this overlapping range, the blue signal is 1, that's moving signal, and stationary signal is e power minus 2 tau. So it is e power minus 2 tau into 1. So whatever is the value of those signals in the overlapping range, we need to write that. So now integrate this. There is no standard integration. Let's not try bring this in that form. So it is as good as doing this, integrating this with respect to tau. So it looks like this after we integrate, and we have to apply the integration limits like this. So is this okay with you? Now, so this is minus 1 by 2 e power minus 2 t plus 2 is tau minus e power 0, that would be 1. So we can write this as y of t equal to half 1 minus e power minus 2t minus 4. And this is for t greater than or equal to minus 2. Yes? Yeah. For t greater than or equal to minus 2. So this is what is the result we have obtained for the range t greater than or equal to minus 2. Now show the summary of this. That means both the results you will show in the same equation. Okay, so therefore let's summarize it. Summary of the result. Okay, so what can that be? Y of t is 0 for t less than minus 2, and it is half 1 minus e power minus 2t minus 4. Okay, for t greater than or equal to minus 2. So this is y of t. So, or it can even be written as, or it can even be written as y of t equal to, what is the range now? For less than 2 it is 0, for greater than or for less than minus 2 it is 0, for greater than or equal to minus 2 it is this. So that means the range of this convolution integral is from minus 2 to infinity. So which is u of t that moves from minus 2 to infinity, which is 1 from minus 2 to infinity? You can just multiply that with this signal. Yeah. Which is that signal, anybody? Which is that u of t? Comment on that. It is u of goes from minus 2 to infinity, right? So it is t minus 2. So it goes from minus 2 to infinity, it is t plus 2. So this is it. Right? So this is one thing, and the same signal can be expressed in this form also. So this is what is the summary of the result we have.